So we are now ready to define trigonometric functions of any angle theta. Okay, so we're gonna be dealing this way in light with the idea of the Cartesian coordinate system. Okay, because we have defined trigonometric functions in such a way that the domains are set of real numbers. But in this case, we're gonna be defining trigonometric function wherein the domain are set of angles or sets of angles. Let us have the Cartesian coordinate system. Okay, and what we're going to do is to draw an angle in its standard position. Let's say, for example, this one. This is the terminal side, wherein the terminal side lies on the first quadrant, meaning to say the angle is located on the first quadrant. Okay, and what we're going to do is to choose any point on the terminal side. Let us name that as point P, wherein since we are dealing with the Cartesian coordinate system, meaning to say point P here has its coordinate, and that would be x comma y. All right, x would be our abscissa or the x coordinate, and the y coordinate or the ordinate. Okay, so this will be our angle, the angle theta. And what we're going to do is, since trigonometric functions are ratios that we derive from a right triangle, then we must have a right triangle here. So for us to form a right triangle, what we're going to do is to draw a perpendicular line from point P down to the x-axis. Okay, so if you notice, we already have our right triangle prior to our angle theta. Okay, meaning to say the distance or the measure of this side of the right triangle would be our x or the abscissa, and then the length or the measure of this side would be y or the ordinate, and the terminal side which happens to be the hypotenuse of the right triangle would be named as r, or let's just name as r. Okay, next, what we're going to do is to now to derive our trigonometric functions of any angle given these conditions that we have here. Okay, so we'll be having the first one, and that is the sine function. So we have defined sine function as opposite over the hypotenuse. So prior to our angle here, what is our opposite side? That would be this side. And this actually contains our ordinate. So meaning to say, sine function would be ordinate over the hypotenuse. Okay, or simply saying that is y over r. Okay, so that will be our first trigonometric function given our condition. Next, we have the cosine function. So cosine theta would be equivalent to, that is actually previously we have defined that as adjacent over the hypotenuse, so which is the adjacent side, so this side of the right triangle, and this actually contains our abscissa. So we have cosine function or the cosine theta would be equivalent to abscissa over the hypotenuse or r. Okay, or simply saying we have x over r. Okay, next we have the tangent function. The tangent function we have defined it as opposite over adjacent, so meaning to say on our condition here, tangent theta would be equivalent to what? To our ordinate over the abscissa. Or simply doing that, we have y over x. Okay? And the other three trigonometric function, which happens to be the reciprocal of the three basic trigonometric function, then we may easily derive them. Okay, first is the reciprocal function of sine theta, and that is the cosecant function. So we have cosecant theta, that is cosecant theta equals, so what we're going to do is just to reciprocate this, so we have hypotenuse over the ordinate. Or simply saying that is r over y. Okay, next would be the reciprocal function of the cosine function, and that is the secant function. So we have here secant theta. What we're going to do is just to reciprocate this one, to reciprocate the cosine function, that is hypotenuse over the abscissa. Or simply saying, that is r over x. And the last trigonometric function would be the reciprocal function of tangent function, and that is the cotangent function. And cotangent function or cotangent theta would be equivalent to, that would be abscissa over the ordinate. Or simply saying, that is x over y. Okay? So these are the the different trigonometric functions that we have derived from our concept here, or from our condition here, in such a way that these are the trigonometric functions of any angle. Okay? Since we are now dealing with the Cartesian coordinate system, expect that we're gonna be dealing with the different signs for the function values. Okay, since may negative at positive signs sa Cartesian coordinate system, so magkakaroon din po tayo dito. So it's much a little, it is more likely more complicated than the previous one. Okay? So let us have an example. Let us have a condition or a situation to solve. Let us have this. It says here that the terminal side of the angle theta in standard position, okay, you always have to take note that your angle must be in its standard position. So the terminal side of the angle theta in standard position passes through a point P, wherein the coordinate of point P is -3, -4. What we're going to do is to draw the theta and find the values of the 6 trigonometric functions of theta. Okay? First things first is for us to, of course, have our Cartesian coordinate system. And let us analyze this. It says here that the terminal side passes through a point P, wherein the coordinates is in -3 and -4. Or -3, -4. Meaning to say, where do you think, or in the four quadrants on the Cartesian coordinate system, where does point P lies? Since both abscissa and ordinate are negative, then meaning to say, point P would be located on the third quadrant. Okay, meaning to say, 3 units to the left of x-axis and 4 units downward of the y-axis. Okay, so that's it. So here is point P, and what we're going to do is to connect, to connect the origin to point P para makuha natin yung terminal side ng ating angle, and this would be angle theta, or the angle measure. Okay, next, what we're going to do is to draw a perpendicular line from point P to our x-axis, so that we'll have our right triangle. So meaning to say, the length of this side would be -3, since it's to the left of the origin. Okay? And the length of this side of the right triangle would be what? That would be -4. Next, we are not given the value of r. So how are we going to find for the 6 trigonometric function of this angle? Okay? Since hinahanap natin dito yung hypotenuse, we can actually solve it using the relationship that we have discussed from our previous discussion, and that is actually using the Pythagorean Theorem. Okay? So, by using the Pythagorean Theorem, we can actually find the value of r. Okay? But since we are not dealing with ABCs here anymore, but we have r, x, and y, so C would be our, or r would be our C, or the hypotenuse. That is r square equals, since x ay si abscissa, or yung first natin na leg would be our abscissa, that would be x square. That would be x square plus the square of the ordinate. Okay? So this is actually our Pythagorean Theorem. And then after that, what we're going to do is just to what? It's just to substitute the values we have on our given problem. Okay? So that's going to be r square. Okay? So let us just copy this one. That is r square equals the value of x would be -3. That is the square of -3. Do not forget to put parentheses, okay? It's just because may rule tayo sa exponent na ang akin ay akin, ang iyo ay iyo. Meaning to say, kapag ganito po, pag ganito, the square root of negative 3, that's positive. But, kung yung exponent natin ay naki 3 lang, then hindi po natin sasama si negative sign. So, it is much different. Okay? And then the value of y would be negative 4. Okay? By by simplification or simplifying this one, the square of negative 3, that would be 9, plus the square of negative 4, that is 16. And then we simplify this one by adding the 2, that's gonna be 25. But since we are just after the value of r, what we're going to do for us to eliminate the exponent here is for us to what? Is for us to extract the root of both sides, making this one the square root of r square equals, that is equals the square root of 25. So in this sense, matatanggal na po yung exponent natin and r na lang yung matitira sa kabilang side ng equation. And you have to remember this. The value of r, the value of our hypotenuse is always positive. Okay? Though nag-extract tayo ng roots, sabihin natin, sir, we extract both positive and negative root. Okay? So you have to remember this, that the value of the hypotenuse or the value of r in this case will always be positive. So meaning to say, the value of r would be positive 5. Okay? Next. So we are now ready to find for the different trigonometric functions of this given angle or the given angle theta. So let us now proceed with the first function, that is the sine function. So the sine function, as we define, that is ordinate over the hypotenuse. So our ordinate would be negative 4. So meaning to say, our sine function or sine theta would be negative 4 over the hypotenuse, which is the value of r, that is 5. Okay, so sine theta would be negative 4 over 5. Okay, next, we are now ready to proceed with the next function. That is the sine function. That's going to be what? We define that as abscissa over hypotenuse or x over r. The abscissa is actually negative 3, so meaning to say, our cosine function or the cosine theta would be equivalent to negative 3 over 5. Okay? Next, let us go down with our third function, and that is the tangent function. Okay? The tangent function would be, sulad ng sinabi natin dito, we have defined tangent theta as ordinate over abscissa. And our ordinate is actually what? Actually negative 4 over the abscissa, which is negative 3. But since they are both negative, so as we simplify that one, tangent theta would be equivalent to positive 4 over 3. Okay? Next, I will explain the signs of the functions later after this one. Okay? Next function would be the reciprocal function of sine, and that is the cosecant function. That is the cosecant function equals, cosecant function, we have defined that as hypotenuse over ordinate. So our hypotenuse is 5, as we have solved for that. That is 5 over, that is ordinate, that is negative 4. Meaning to say, cosecant theta is equal to 5 over negative 4. Okay, next is the reciprocal function of cosine, and that is the secant function. That is secant theta would be equivalent to, we have defined it as hypotenuse over abscissa. Meaning to say, that is hypotenuse, which is 5, and abscissa, which is negative 3. Okay? So, secant theta would be 5 over negative 3. And the last trigonometric function would be the cotangent function. So, cotangent theta would be equivalent to the reciprocal of tangent. That is abscissa over ordinate. Our abscissa is negative 3. And our ordinate is negative 4. Since both numerator and denominator are negative, then we can actually simplify this as positive 3/4. So here are the different trigonometric functions we can derive from our given situation. Okay? So here it is. If you notice, if you notice, there are signs. The following trigonometric functions of the angle have signs. So we have to take note of this. Okay? Let us go let us go back to our Cartesian coordinate system. Since in the first quadrant, the abscissa and the ordinate are both positive, meaning to say all ratios that you can extract from there will always be positive. So meaning to say, if the angle is in quadrant 1, then all functions would be positive. Okay? But if we have here or if the angle lies on the second quadrant, meaning to say its abscissa is negative, or the x value is negative, and the y value is positive, or the ordinate is positive, meaning to say those with those functions that concerns abscissa would be negative, because that is negative, and that is only the sine function and the cosecant function. Okay? Next, if the what do you call this? If the angle that we are after to lies on the third quadrant, meaning to say both abscissa and ordinate are negative, meaning to say those functions with both abscissa and ordinate in them would just be the function that is positive. All right, and that is the tangent and its reciprocal, which is the cotangent function. So if you notice here, since our angle lies on the third quadrant, the tangent function and the cotangent function are positive. All right, and then the rest are negative. Okay, and the last one, if the angle falls on the fourth quadrant, then since si abscissa ay positive at si ordinate naman ang negative, then that would be what? That would be, or those functions that contain the ordinate, which is the negative one, would be negative. Okay, and the only positive would be the cosine theta and the secant theta. Okay, so you have to remember this. Again, in quadrant 1, all functions are positive. On quadrant 2, only sine and its reciprocal is positive. On quadrant 3, only tangent and its reciprocal are positive. And on the fourth one, only cosine function and its reciprocal are negative. Actually, you can memorize this using a mnemonic device. I use ASI-TACO as a mnemonic device to this, meaning to say A on the first quadrant, that is A, meaning all positive. C, ASI, meaning to say sine function and its reciprocal is just the positive one. Ta, meaning the tangent and its reciprocal are the only ones positive. And TACO, cosine and its reciprocal would be the only ones positive. Okay, so much better if we would have ASI-TACO. Okay, so let us have another problem. It says here that if sine theta is 5/7 and tangent theta is greater than 0, draw theta and find the other 5 trigonometric functions. So it is somewhat complicated, but let us digest each and every condition on the problem. Okay, first things first is for us to digest, sabi dito, if sine theta is 5/7. Let us digest. We have represented sine theta. Okay, again, we have represented sine theta as, tulad ng kanina, sine theta is ordinate over hypotenuse. Alright, that is ordinate over, okay, again, that is sine theta equals ordinate over hypotenuse. Okay, or simply saying that is y over r. And since given na yung sine theta, ang sabi dyan, that is 5/7. That is 5/7, meaning to say your abscissa Your abscissa is what? Your abscissa is, or sorry, your ordinate is 5 and your hypotenuse would be 7. Meaning to say, saan kaya natin malolocate ito? Saang quadrant positive? Kung mapapansin natin, sine function here is positive. In which quadrant positive si sine function? Balik tayo dito. Saan quadrant kaya papatak for our first condition that sine function is positive? So it is just either quadrant 1, since all functions here are positive, and quadrant 2. So those are the only ones or the only possibilities. Okay? Next, let us proceed with the second condition. It says here that tangent theta is greater than 0. So when do we say that a certain number is greater than 0? So greater than 0 siya kapag positive. So meaning to say, the second condition is that our tangent function would be positive also, aside from sine function. Balik tayo. Saan kaya dito positive yung tangent function? That is quadrant 1 and quadrant 3. Okay, that is our second condition. But on our first condition, it's just either quadrant 1 and quadrant 2. So meaning to say, the angle falls on the first quadrant since dito both positive yung sine at saka yung tangent function. Okay? So we have just realized that the point on the terminal side, or simply saying the terminal side, lies on the first quadrant. So let us now draw. Okay, if this is our Cartesian coordinate system, that would be, or point P would be here. Okay, but we don't have any values for our abscissa yet. So what we're going to do is what? What we're going to do is to first solve for our abscissa using the Pythagorean Theorem. Okay, so that would be r squared equals x squared plus y squared. And we all know that the value of r is 7, so that's gonna be 7 squared. 7 squared equals, since we don't have abscissa yet, so that is x squared plus the value of y, which is 5. So that is 5 squared. And then, simplifying this one, the square of 7 is 49. And then, since we are looking for the abscissa, will remain x as it is. That is 49 equals x squared plus the square of 5 is 25. And then simplifying this by combining like terms, that's gonna be 49. That's 49, and then we transpose positive 25 to the other side, making that negative 25 equals x squared. Okay? And then simplifying this, we have 24 equals x squared. That is 24 equals x squared. Okay, and then extracting the root of both sides, that's going to be x equals the square root of 24. And if we simplify the square root of 24, that is actually what? That is, we can actually have x equals the square root of what? The square root of 4 multiplied by 5. Okay? Or 6, sorry. Okay? And if we simplify that, the value of x would be 2 square root of 6. Okay. So that's it. This will be the value of our abscissa. That is 2 square root of 6. So we already have our 3 coordinates. The abscissa as 2 square root of 6. The ordinate as 5. And our r, or the hypotenuse, is 7. Okay? So we are now ready to locate point P. Okay? So it is somewhere here. Okay, so point B would be at, since abscissa ang laging nauna sa coordinate, that is 2 square root of 6, 5. And then, and then we connect point P and then the origin to have our terminal side. So our first realization that the conditions, or we have realized that this condition tells us that the angle falls on the first quadrant. Okay? So our value of x, okay, the value of x would be 2 square root of 6, and then the value of y would be 5. So we are now ready to, and then the value of r is 7, of course. So we are now ready to determine the different trigonometric functions of this angle. So we have, since we are given the sine theta already, so hindi na po natin siya hanapin. So we're just to look for the other 5 trigonometric function, and that is the cosine theta. First, cosine theta would be equivalent to, cosine is what? Cosine is abscissa over the hypotenuse. So that's going to be 2 square root of 6. That's going to be 2 square root of 6 over 7, since 7 is our hypotenuse. Next, we have the tangent theta. Tangent theta would be, sabi natin, tangent theta is ordinate over abscissa. Okay? So our ordinate is, the ordinate is 5 over our abscissa, which is 2 square root of 6. Okay? But since, tulad ng sinabi ko, kapag ganito, you have radical signs or you have radicals on the denominator, you can actually what? You can actually rationalize it by multiplying it with the conjugate. So, using your calculator, it is easy because automatic na po siya. Let's say, for example, we have 5 over 2 square root of 6. Once you press equals, automatic na po na nakakuha niya yung, nara-rationalize niya na yung ating given. So that's gonna be 5 square root of 6 over 12. Okay, so that will be our tangent function. Okay? Alright. Next, we have the cosecant function. The cosecant function is just what? It's just the reciprocal of the sine function. So the sine function is already on the given. So that's going to be what? That's going to be 7 over 5. Next, we have the secant function. The secant function is what? The secant function is, it's just the reciprocal of the cosine function. So let us just reciprocate this one. So that is what? 7 over 2 square root of 6. But then again, since we have radical signs, since we have radical sign on the denominator, radical on the denominator, let us rationalize that one. So that's going to be what? 7 over 2 square root of 6. Okay, so that's gonna be what? 7 square root of 6 over, that is 7 square root of 6 over 12. Over 12. And the last function would be the cotangent function, wherein the cotangent function is just the reciprocal of the tangent function, and that would be what? That would be 2 square root of 6 over 5. Alright, so here are the different trigonometric functions we can derive from our given problem. And let us check this one. Sabi natin yung tangent natin should be positive. Positive ba si tangent? Yes, it is. Okay? And so with its reciprocal. Okay? So we have just derived, or we have just found the other 5 trigonometric functions to our problem.